Have you ever wondered what computing might look like beyond the limits of classical computers? What if we told you that there's a technology on the horizon that can outperform even the mightiest supercomputers in the world today? We'll explore 3 key points that are set to reshape the landscape of technology as we know it. Point 1. Quantum supremacy. Our first point is quantum supremacy. Imagine a computer that can perform calculations so complex that even the most powerful supercomputers on Earth today pale in comparison. Well, that's what quantum supremacy represents. It's when a quantum computer can solve a problem faster than any classical computer ever could. Quantum supremacy was first demonstrated by Google in 2019 when their quantum processor, Sycamore, solved the problem in just 200 seconds that would take the most advanced classical supercomputer over 10,000 years. This achievement has opened up new possibilities in fields like cryptography, drug discovery, and optimization problems. Point 2. Quantum applications. The second point we'll explore is quantum applications. Quantum computing isn't just about solving complex math problems, it's about transforming industries. Quantum computers excel in areas like cryptography, simulating molecular interactions, and optimizing logistics. In cryptography, quantum computers could potentially break current encryption methods, which has spurred the development of quantum-resistant algorithms to secure our digital future. In drug discovery, quantum computing can simulate and analyze molecular structures, potentially revolutionizing the development of new drugs. And in logistics, it can optimize supply chains, reducing costs and environmental impacts. Point 3. Quantum challenges. But it's not all smooth sailing in the world of quantum computing. Our third point focuses on quantum challenges. Quantum computers are incredibly powerful, but they are also incredibly delicate. They need to be kept at ultra-low temperatures to function, and they are highly susceptible to noise and errors. Overcoming these challenges is crucial for quantum computing to reach its full potential. Researchers are working on error correction techniques and developing more stable qubits. Additionally, there are concerns about the security implications of quantum computing, as it could break current encryption methods. The future of quantum computing is incredibly exciting, with the promise of quantum supremacy, groundbreaking applications, and transformative capabilities. However, we must also address the challenges ahead to fully unlock the potential of this revolutionary technology. If you're interested in the future of tech, be sure to subscribe to our channel for more updates. Thanks for watching, and we'll see you in the next video.